Chromatography is a physical technique for the separation in which the components to be separated between two phases which are stationary phase and mobile phase in a definite direction. The word chromatography is derived from a Greek word where chroma means color and graphene means to write. This method is widely used for separation, identification, and determination for the chemical components in complex mixtures. Chromatography is mainly divided into two types, which are planar chromatography and column chromatography. In planar chromatography, the stationary phase is applied as a thin layer on a flat support material such as glass, plastic, or aluminium. This thin layer is typically composed of materials like silica gel or alumina, which have adsorptive properties. The sample mixture is applied as small spots or lines onto the stationary phase. The separation process begins when a mobile phase, usually a liquid solvent, is allowed to move across the stationary phase through capillary action or by placing the plate in a developing chamber. As the mobile phase moves over the stationary phase, different components of the sample interact with the stationary phase to varying degrees. This differential interaction causes the components to separate spatially on the plate. Planar chromatography is valued for its simplicity and ease of use, requiring minimal equipment and setup compared to other chromatographic techniques. It is particularly useful for qualitative analysis, quickly identifying the presence of components in a mixture based on their migration distances and retention factors. In contrast, column chromatography involves a stationary phase packed into a vertical column or tube. The stationary phase is typically a solid support material which fills the column. The sample mixture is introduced into the top of the column and interacts with the stationary phase as a mobile phase, usually a liquid solvent, flows downward through the column under the force of gravity or pressure. Components of the sample mixture move through the column at different rates based on their affinity for the stationary phase. This differential movement results in the separation of components over time. Column chromatography offers higher resolution and better separation efficiency compared to planar chromatography, making it suitable for both qualitative and quantitative analysis. It is widely used in research laboratories and industries for tasks such as purifying compounds, isolating specific components from mixtures, and analyzing complex samples in detail. Chromatography offers several advantages which make it a versatile and powerful analytical technique. One of its primary strengths lies in its high-resolution capability, allowing for the effective separation of complex mixtures into individual components. Additionally, chromatography facilitates sensitive detection, capable of identifying trace amounts of substances, which is essential for analyzing samples with low analyte concentrations. Lastly, chromatography is used in diverse fields including pharmaceuticals, environmental monitoring, food analysis, forensics, and biochemistry. However, chromatography does come with certain disadvantages. Setting up and optimizing chromatographic methods can be complex, requiring expertise and meticulous attention to detail. The process can also be time-consuming, particularly for complex mixtures or when high resolution is necessary, as it often involves lengthy equilibration times and precise parameter adjustments. Finally, the cost of chromatographic equipment, consumables like columns and solvents, as well as ongoing maintenance can be significant as it can be expensive.
The objective of chromatography experiment: the first one, to separate food dyes using paper chromatography. The second one is to analyze components of a mixture based on their differential interaction with a stationary phase and a mobile phase. Theory of chromatography: stationary phase, solid or liquid form that fix in a place to absorb the component that is being separated. Mobile phase, in form of liquid or gas that is moved over stationary phase as carrier for mixture to pass through the stationary phase. Adsorption. The stationary phase adsorb molecule based on their affinity, while the partition chromatography. The stationary phase partition solutes based on solubility. Separation. The differences in mobility for component in sample will separate out into discrete band that can be analyzed qualitatively and quantitatively. Elution is the process in which solutes are washed through a stationary phase by the movement of a mobile phase. Eluent is the solvent used to carry the component of a mixture through a stationary phase. And the last one is eluent, is the mobile phase containing anides that exist the column.
Next is the methodology of paper chromatography. Firstly, a line of parallel was ruled to the short dimension 3 cm from the bottom edge of chromatographic paper with a pencil. Second, 4 small X was marked along the line equally distant or about 3 cm from each other. At the bottom of each X was labeled with red, blue, green, and yellow. Next, prepare the developing solvent by dissolving 2 grams of NaCl in 100 ml water and pour about 70 ml of the solvent in a clean dry 1000 or 2000 ml beaker. And then the chromatographic paper was laid on the table. A microcapillary was used. A tiny spot was placed of each foot dye on each X mark. Repeat if necessary. After that, clamp and retort stand or either a glass rod or pencil was used. The paper was hung and slowly immerse the paper in the beaker containing the dissolving solvent. Make sure that the paper does not touch the wall of the beaker and the level of the solvent is below the line ground. The solvent was allowed to rise until about half distance. The paper was taken out from the beaker. The solvent front was marked. Lastly, let the paper dry for 5 to 10 minutes to draw line for the solvent front that has been marked. Next, we move to the result of paper chromatography. From the table, as you can see, all color remain the original color except for green color. For blue, the color of spot is blue and the height of spot is 8.8. This height of solvent front is 8.9. The RF value for blue after divided 8.8 with 8.9 is 1. For green in color, the color of spot is blue and yellow. The height of spot for blue is 8.0 and yellow is 4.2. The height of solvent front is 8.9. The RF value that we got for blue after divided 8.0 with 8.9 is 0.9. And for yellow, after divided 4.2 with 8.9 is 0.5. Next, for red, the color of spot is remain in original color. The height of spot for red is 5.6 and the height of solvent front is 8.9. The RF value that we got after divided 5.6 with 8.9 is 0.6. Lastly, for yellow, the color of spot also remain in original color. The height of spot for yellow is 5.3 and the height of solvent front is 8.9. The RF value that we got after divided 5.3 with 8.9 is 0.6. Next, hear the video how the food dye is observed in 20 minutes duration.
To sum up, chromatography is quite useful. It is frequently employed in labs for the isolation of novel substance, the analysis of minute variation between various environmental samples, and even DNA sequencing. In this experiment, the food colors of blue, red, and yellow represent pure things, whereas the food color of green represent impure substance. All things considered, the experiment objective was accomplished.